Good day, everyone. Now, let us look at the solution to the practice questions that we gave in our last class. 500 grams of water is heated so that its temperature rises from 30 degrees Celsius to 72 degrees Celsius in 7 minutes. Calculate the heat supplied per minute. Now, we know that we have to bring out our parameters from the question. That is the first thing. Now, 500 grams of water means that the mass of water is 500 grams. So I'm going to write that mass is equals to 500 what? 500 grams. But we know that our mass should be in kilogram. We know that our mass should be in kilograms. So I'm going to say, I'm going to divide this 500 by 1000 to make sure that the mass is in kilogram. So I'm going to do this. This is going to be 500 divided by 1000. That's going to be, and that's going to be 0.5 what? Kilogram. Now, our mass is now 0.5 kilogram. Now, the next thing is we continue to read the question to bring out other parameters so that its temperature rises from 30 degrees Celsius to 72 degrees Celsius. So the temperature rise now is going to be delta T, meaning the temperature rise is going to be equals to T2 minus T1. So, which is going to give us what? 72 degrees Celsius minus 30 degrees Celsius. And that is going to give us what? That is going to give us 42 degrees Celsius. That is the temperature rise. Now, in 7 minutes, well, let us bring out this time also because we are going to need the time later, but not now. So our time, I'm going to write it in full, equals to 7 minutes. But remember that we are trying to calculate the heat supplied first. Now, if you are trying to calculate the heat supplied, you should have an idea of the formula you are going to use, which is the quantity of heat supplied is equals to M, the mass of the body, times the specific heat capacity of the body times the temperature rise. But now the question did not give us the what? The specific heat capacity. But this is water. So everyone should have an idea of what the specific heat capacity of water is. So I'm going to write now, the specific heat capacity of water is 4,200 joules per kilogram per Kelvin. So my C is going to be equals to 4,200 joules per kg per Kelvin. So that is the specific heat capacity of water. Now I'm going to calculate the quantity of heat supplied. So we know that we are going to use this formula Q is equals to the mass times the specific heat capacity times the temperature rise to calculate our what? To calculate our quantity of heat supplied, which is going to be equals to the mass from the question is now 0.5 what? Kg. So which is 0.5 multiplied by the specific heat capacity of water is 4,200. So which is 4,200 multiplied by the change in temperature, which is temperature rise, is 42. So this is going to be times 42 here, right? So that is what we are going to multiply right now to get the quantity of heat supplied. Now I'm going to multiply this. This is going to be equals to, for this, I can say 5/10 because, you know, if you realize from here, if we cancel 2 zeros here, we are going to have 5/10. So, but if we put it in decimal, that's where we are going to have 0.5. But I'm changing it here because I want to cancel zeros. But if you are using your calculator, there's no problem about that. So we're going to have multiply by 4,200 multiplied by 42. Yes, so this 0 is going to cancel this 0 like this. So I'm going to have, what I'm going to have left is going to be equals to 5 multiplied by 42, 420 rather, times 42. Now you can do this calculation using your calculator, but I'm going to do it and I'm going to multiply everything together. So first, I'm going to multiply 42 and 42 together. That's the first thing I'm going to multiply. So I will multiply that somewhere. So that 42 times 42, that is going to be 4. That's going to be 8. That's going to be 8. That's going to be 16. So I'm going to add this together. That's going to be 4, 6, 7, and 1. But remember that it's actually 420. So I'm going to add this 0 to the back. That's going to be 17640. So that I'm going to have 5 times 17640. So I'm going to multiply 5 times 17640 now. 17640 times 5. So 5 times 0 is 0. 5 times 4 is 20. I'm going to write 0, remainder 2. 5 times 6 is 30 plus 2, that's 32. So I'm going to keep 3. 5 times 7, 35 plus 3, that is going to be 38. So I'm going to write 8. I'm going to keep 3. So 5 times 1, 5 plus 3 is going to be 8. So which is going to give me what? 200 what? 200 joules. So meaning that the quantity of heat supplied is actually 88,200 joules of heat is actually supplied. Now remember that we are just trying to elongate this because we are trying to multiply it without using calculator. But from here you can get your answer. Just multiply everything, and in the next line you're going to get your answer. But now remember to put your unit at the end of the day. The reason why we do not put all the units of each parameter is because it's for simplicity. You understand? Now, but remember, we are not done with this question. The question says calculate the heat supplied per minute, because the question said the heat so that its temperature rises from this 30 degrees Celsius to 72 degrees Celsius in 7 minutes. So which means that the total quantity of heat that we have calculated now is actually the heat supplied in 7 minutes. In 7 minutes. So to get the heat supplied in 1 minute, we have to do what? We have to divide. Yes, we have to divide. So we have to divide the quantity of heat supplied in 7 minutes by 7. And when we divide by 7, we are going to get the quantity of heat supplied in 1 minute. So that's what we're going to do now. So meaning that the quantity of heat supplied in 1 minute is going to be our Q will now be equals to 200 divided by 7. 200 joule divided by 7. So which is going to be equals to, so how many 7 are we going to see in 8? It's going to give us 1. So remember, it remain 1. So how many 7 are we going to see in 18? It's going to give us 2, right? So that's going to remain like 4. 7 times 2, 14. So remain 4. I'm going to put it here. So 42. So 7 in 42 is going to give me 6, right? So I'm going to have 6 here, right? So 00 joule. So the quantity of heat, the Q, the quantity of heat in 1 minute is equals to 1200 joules. Sorry, is equals to 12600 joules. So the quantity of heat supplied in 1 minute is going to be 12,600 joules. So that is how to calculate, how to solve this question. I hope this is okay. Thank you.